we're talking about Chapter 3, Section 4, perpendicular lines. So the first two sections, or the last two sections that we were talking about, were all about parallel lines. Now we're talking about perpendicular lines. Your objective is to prove and apply theorems about perpendicular lines. The objective doesn't really give you a lot of information, so you might want to write your essential question after you've done all of your notes. If you can come up with an essential question now, though, go ahead and pause the video and write it down. The first thing we need to talk about is the shortest distance from a point to a line. If I have point P here and line L there, I can draw lots of different options of lines from P to L, but the shortest distance is going to be the line that is perpendicular. So the line that intersects at a 90-degree angle. Which brings us over here. You have the shortest segment from A to B. A is this point out here. Excuse me, not B, BC. And BC is this line here. Is AC the shortest segment, or is AB the shortest segment? Well, AB is the shortest segment because it intersects at a 90-degree angle. It's the perpendicular line. So AB is the answer to that first question. B says write and solve an inequality. Well, we know that if this is the shortest segment, then that means AC is longer. So my inequality is going to be x minus 5 is a smaller distance or less than 12. Then you can solve, add 5 to both sides. You get x is less than 17. Okay. Theorem time. I didn't write down any of the words, but if you want to get the exact wording, you can look it up in your textbook. I'm just going to explain what they mean. So the first theorem that we have is two intersecting lines form linear pair of congruent angles. If two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. Now that's a really long title. This theorem doesn't actually have a name, so its name is kind of like its definition. What it means is if I have two lines that cross and both of these angles are the same or congruent, then that means that they're going to be perpendicular because they have to be 90 degrees. They're exactly the same, it's going to be 90. Any sort of variation is going to make one smaller than the other. So if I have two lines that cross and both of those angles are the same, then L and M are perpendicular. The next theorem actually has a title, so this one's called Perpendicular Transversal Theorem. This theorem, again, if you want the actual wording from your textbook, look it up, copy it out of the book, or you can just write your own version of what it is that I'm saying right now. If I have two lines that I know are parallel, so that's given, and I have another line that intersects one of the parallel lines at a 90-degree angle, so it's perpendicular, then I know that it's also going to be perpendicular to the other one. So this theorem says that if I have two parallel lines and a transversal, and my transversal is perpendicular to one of them, I know that it's also perpendicular to the other one. So Q is perpendicular to P. Line Q is perpendicular to line P. Third theorem, it's another one without a title, so its title is almost the same thing as its definition. If two lines are perpendicular to the same line, then the two lines are parallel. So here's my image for the theorem. I have two lines, and both of these are perpendicular to the same line. Because they're both perpendicular to the same line T, R and S are parallel. It's almost the opposite of this one, where I know they're parallel to begin with, which means that if it's perpendicular to one, it's also perpendicular to the other. This one tells me if they're both perpendicular, then I know that they're both going to be parallel. Alright, so here's your practice problem. I covered up the proof. I did pre-write it though so that you wouldn't have to be waiting for me to be writing it down. This is our question. So this is the image that they give you. The given information is that R and S are parallel. And actually, since that's given, I'm going to label it on my picture. R and S are parallel, and angle 1 is congruent to angle 2. So I'm also going to label that in my picture. Angle 1 and angle 2 are congruent. So if you take a look, obviously given is the easiest step. It's given. It's not a whole lot of thought that goes on there. But if you know that R and S are parallel, what else do you know about this image? Well, if R and S are both parallel, and I have a transversal that cuts through it, I have angle 3 and angle 2 that are going to be congruent. And I know that they're congruent because R and S are parallel. How do I know that angle 2 and angle 3 are congruent? Because they're corresponding angles, and the corresponding angles postulate says that if they're parallel, the corresponding angles are congruent. Next step. I know proofs is hard for a lot of us right now. I have this piece of given information here, and this piece of information that I came up with because of the corresponding angles postulate. If you take a look at these two, can you combine them somehow using a different theorem or postulate that you've learned? I have angle 1 congruent to angle 2, angle 2 congruent to angle 3. Both of these angles are congruent to the same thing. What's that called? Do you remember? Alright. If you said transitive property of congruence, then you were right. Transitive property says that I can take these angle 2's out and set angle 1 congruent to angle 3 because they're both congruent to the same thing. Alright, last step. Last step is also one of the easiest. It's kind of like given, where the first step is really easy because all you have to do is copy the given. The last step is always really easy because all you have to do is copy what you were supposed to prove. We had to prove that R and T are perpendicular. So what we've done here, now that we know that angle 1 and angle 3 are congruent, that means these two are the same measure, I know that my two intersecting lines form I have two intersecting lines that form a linear pair of congruent angles. These are my linear pair because they create a line of congruent angles. That's what we proved right here in step 3. So now I know that my lines are perpendicular. If you have any questions, please make sure that you write them down so that we can talk about them tomorrow. Don't forget to go back and write your essential question if you haven't done that, and make sure that you write your summary. See you tomorrow.